Hi, kids. All right, hey, this will be a short video talking about the egg drop. Just want to give you a couple hints and talk a little bit about center mass, make sure that makes sense. So, with the egg drop, you're going to make some paper egg device that when you drop it to the ground, hopefully it's going to protect your egg. Most of the time, when the kids just take their 5 sheets of paper and kind of just crumple it around there, yeah, it doesn't work. Most of the time, the egg is not protected. But there are a couple things that I want to make sure we're going to use this setup to talk about two different things and make sure it makes sense. First, I really want you to make sure you understand what time we're talking about. So from A to B, does the momentum of the egg change? It does. Why does it change? Because there's a force of gravity acting on it. But is that the force you're trying to minimize? No. In fact, you can't do anything to the force of gravity. The force of gravity is m times g, and that's going to be set. So, and plus, how often does an egg, when you drop it, spontaneously explode in the air? Yeah, never. Um, so, really, what we're worried about is the force from the ground, which that time we're talking about is the time from the instant your device hits the ground until your egg stops. So it'd really be the time from here, B to C, where this is the instant it hits the ground and this is where it first fully stops. That's the time we're talking about. So here's what I've had students do in the past, and I want to make sure you don't do it, and we'll talk about why. I've had students go, all right, so I want to make this contact time really big, so that this force is going to be really small as long as that change in momentum is the same. Because, if once your egg hits the ground, no matter what happens, the change in momentum of your egg is going to be the same. It's going to go from something to nothing. So I've had students that go, all right, well, I know I want to increase this time, so here's what I'm going to do. I'm going to make this long tube and I'm going to have all this padding in here and have my egg up there so that when it hits the ground, you see all that increased stopping time. But here's the problem, okay? It relates to center of mass. Now, we've talked about center of mass before, but it's a good idea to bring this back up again. The center of mass of the system is the center of the system's mass distribution. So if you have 5 sheets of paper and an egg, guess where the center of mass is going to be? Yeah, in the egg, because almost all of the mass of your object is going to come from the egg. So it's going to be right here in the egg. Well, the center of mass of a system, okay, when you drop it, when you just let it be, it wants to get as low as possible. So guess what's going to happen? If you were to drop this thing, by the time it hits the ground, it would have flipped. So your egg is down here, and there's all this padding above it. And yeah, that would be a really short stopping time, which means your egg is going to explode. So our goal is not to scramble the eggs. So it is to figure out how to prevent your egg from breaking. So there are some things you can do that if you set it up like this, that to force it to stay like that. I'm not going to say what they are because part of this is you guys are designing it. But just be careful. Don't just do this, because if you do this, it's going to end up like this. Okay? All right. Best of luck with your designs. Bye, kids.